Here we have a review of Chapter 2.8. A linear inequality is similar to a linear equation, except the equality symbol is replaced with an inequality symbol, such as less than, greater than, less than or equal to, or greater than or equal to. All of these are inequality symbols. And a solution of an inequality is the value for the variable that makes the inequality a true statement. And the solution can be graphed on a number line, and it can be written different ways. So let's take a look at this solution here. You see that there's a shaded area in blue that starts, it goes up until 7 and it stops. So if we were to look at this from the least to the greatest value, that would be negative infinity on the least, up to 7 on the greatest. And we don't include negative infinity because we'll never actually count that number. It's not a real number, it's a theoretical number. But 7, you'll notice that there's a bracket symbol, and that means that the 7 is included in the solution, meaning 7 will make the inequality statement true. The parenthesis means not included. So if you have a value that actually doesn't make the statement true, but up to that number makes the statement true. So that's the solution in the interval notation. In the set notation, we would say that the solution is the set of x such that x is less than or equal to 7. Of course, x is a real number. If you want to write that in there too, that makes sense, but it's implied if we don't write it there. So steps for solving linear inequalities, same steps as solving linear equations. First, you can clear the fractions or decimals. It's optional, but a very good step to take. I always use it. Step 2, you have to use the distributive property to remove grouping. And sometimes that leads to like terms on either side. You want to combine those in step 3. And step 4 is to actually move terms by oppositing them from both sides of the symbol, the inequality symbol. And step 5 then is to get that variable to be the only factor on its side of the inequality statement by multiplying the reciprocal or undoing the operation that's being done to it. And the last step is to check your solution. Of course, with inequalities, you have many solutions, but if you at least check one side of the number that you found in your solution, that will guarantee that you have shaded and chosen the correct side of that number for your solution space. There's one difference, though, for solving inequalities. And that is if you multiply or divide by a negative number, that's going to flip your whole statement over the other side. So that's going to flip the inequality symbol as well. Instead of going greater, now it'll be less. Or if it was less, now it's greater. It's going to flip that symbol if you multiply or divide by a negative number. So let's solve a simple inequality. That means there's only one inequality symbol. And we'll graph that solution on the number line and write the solution in interval notation. So we do have parentheses, so we need to distribute to remove that parentheses on the right side of the inequality symbol. 2 times x is 2x, and 2 times negative 3 is minus 6. Then I want my variable terms to be on the same side, so I'm going to subtract 2x from both sides. Then I'll have negative 7x plus 7 on the left side, and minus 6 on the right side. Then I want my number terms to be on the other side, so I'm going to minus 7 from both sides. Then negative 7x is less than negative 13. And finally, I need to get x to be the only factor, so I'm going to divide negative 7 from both sides of this statement. Then I'll have x on the left side and a positive 13/7 on the right. But I divided by a negative number, So that means flip it. Flip the symbol. Okay. And so my reference number on the number line is 13/7. I don't really care what that is, a decimal or mixed number. It's 13/7. That's fine. And I need all numbers greater than that. So greater is to the right of. So all of these numbers are solutions to the statement. Do I include 13/7 as part of my solution? If I put 13/7 in for x, does that make that true? Well, no, 13/7 is not greater than 13/7, so not included, parenthesis. And that means my interval is from least, 13/7, to greatest, that's positive infinity. All right, positive infinity on the right side, negative infinity on the left side. And if I want to verify that's true, I need something, let me test something less than 13/7. So maybe I do need to know approximately what that is. And that's not quite 2. So, well, why don't I try 0? That'll be easy to test. So let me test that. Check x equals 0 and see if it's true in the original statement. So negative 5 times 0 plus 7 is less than 2 times 0 minus 3. Well, that's 0. So 2 times negative 3, that's negative 6. And that's not true. So good thing I didn't include 0 in my solution, because that would not be true. So that gives me a good idea that I shaded the right side of this. Compound inequalities contain more than one inequality symbol. And we want to solve this compound inequality here, graph it on the number line, and write the solution in interval notation. So you'll see that there's 2 inequality symbols here. So that kind of cuts this up into 3 parts: the left side, the middle, and the right side. And your variable is in the middle. So that is where I'm going to apply my focus, in the middle. I want that variable to be the only term and the only factor in the middle. So I have to undo the other term in the middle. I'm going to subtract 4 from all 3 parts of this. So on the left, that's negative 1. In the middle, that leaves just the x term. And on the right, that's positive 1. So then I need to get rid of this factor of 3/2, and I can get rid of it by multiplying the reciprocal. So I'm going to multiply 2/3 to the left side, the middle, and the right side. So on the left side, that's going to be negative 2/3. In the middle, that's going to be 1x, or just x. And on the right side, that's going to be positive 2/3. So now you can see that our variable is between 2 values. Does it make sense? Negative 2/3 is on the left, positive 2/3 on the right, and our variable is everything in between those 2 numbers. That makes sense because it's in the proper order of the number line, right? So do we include those numbers? Hey, there's an equals to symbol there. Yep, we include those numbers because they will also make this statement true. So any number between negative 2/3 and positive 2/3 is the solution to the variable that makes the original statement true.